Hello everyone. In my previous video we have discussed about the introduction part for complex number. So there I have explained about the imaginary number or the definition for complex number and the real part and imaginary part of complex number, the representation for complex number and also the representation for root of negative numbers, which is nothing but I. And also we have discussed about the powers of I. Okay, so the link for the same video is in the iCard above. So those who want to see that video can watch that video by. Okay, so now in this video we'll continue with the concept, that is a complex number. So this is the second video of complex numbers. Okay, so let me continue. So in the previous video we have seen that the powers of I. So there I had told you that I is represented by or square root of negative number, which is nothing but square root of -1 can be represented by I. Okay, so and also we have seen the value of I square, which is nothing but -1, the value of I cube, which is nothing but -I, value of I to the power 4, which is nothing but 1, and in general we can represent value of I to the power 4n, which is nothing but 1. So any number or any power to I can be represented in terms of these values. Okay, fine. Now let me take few more powers. Now when I say I to the power -1, this is nothing but 1 by I. So let us find out what is the value of 1 by I. So for this let me take I square. So what is I square? I square is I into I. Okay, so I square value is what? It is -1. So this is -1. So let me write these two, this equality expression. So what I am getting is, so I is equal to -1 by I. Is that correct? So what I have done is I into I is equal to -1. So from this I have taken 1I to the other side. When it goes to other side, it goes to the denominator, that is nothing but division. So I is equal to -1 by I. So I can write from this, so 1 by I is equal to -I. This is by multiplying -1 on both sides. So if we multiply -1 on both sides of this expression, what do we get? We get 1 by I. That is what we wanted, 1 by I. So 1 by I is equal to -I. So I to the power -1 is 1 by I, which can be written as -I. Okay. Okay. Similarly, we can write I to the power -2. So I to the power -2 is 1 by I square. Now we know the value of I squared. So this can be written as 1 by -1. I square is -1. So this is nothing but -1. Okay, fine. Next, what we have is I to the power -3. So 1 by I cube it is. So 1 by I cube is -I. Okay. So we have -1 by I from this. So this can also be written as minus of 1 by I. We have seen 1 by I is -I. So I can write -I over here. So this is nothing but I. Similarly, I to the power -4 can be written as 1 by I to the power 4. So this is nothing but 1 by I to the power 4. We have seen it is 1. So it is 1. So this value is 1. Similarly, we can find out value of any power to I. Okay, so these are very important results to be remembered to calculate any expression using imaginary numbers. Okay, so let me take a few examples. So let me take one example. So evaluate. Let me take one example. So where it is given, evaluate I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3 for any positive integer n. Okay. So let me take the expression. So it is I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3. Now from this it is I to the power n plus, now this power n plus 1 can be splitted to two powers with the same base, that is nothing but I to the power n into I to the power 1 plus I to the power n, this as I to the power 2, that is I square, plus similarly this I to the power n into I to the power 3. How did we do this? So this is based on the equation a to the power m plus n can be written as a to the power m into a to the power n. Okay. So now in all these terms I to the power n is common. So factorizing, so let us write I to the power n common out. So what do we get? So if I take I to the power n out, so 1 plus here I plus here it is I square plus here it is I cube. Okay. Now let us substitute the values of these. So we have I to the power n, so 1 plus I, let me write as it is, plus what is I square? It is minus 1 plus what is I cube? It is minus I. So we have I and minus I, 1 and minus 1. So inside it is 0. So 0 into I to the power n is 0. So this is how we apply the basic concept of imaginary numbers. Okay. So let me take one more example. So it is a question. So we have to find out the value of this. Okay. Now here the question is given as a fraction. So there is numerator term and also denominator term. Okay, so we have to simplify this. Now as it is, I can find out the values of these individual term. How to find out? So you just represent this as I to the power 4 n plus or plus something. Okay, that can be done. Or before that, let me take common out from all these terms so that the powers gets minimized to a smaller number. I mean, see here I to the power 384 is the minimum power which I have in the numerator side. So denominator part 374 is minimum. So what I do is, let me take I to the power 384 out. So what you will be getting? I to the power 384 if I take out. So what is there? It is 8. I to the power 8 plus here 384 if we take, then it is I to the power 6 plus here if we take, it is I to the power 4 plus here it is I to the power 2 plus here it is 1. Okay. So this, and how it is 1? Because it is I to the power 384 is taken out, so into 1. So it is I to the power 384 into 1 is I to the power 384. I to the power 384 into I to the power 8 is I to the power 392. Okay. Similarly, from the denominator I can write I to the power 374 common out. So what I will be getting is I to the power, here it is 8 again, plus I to the power 6 plus I to the power 4 plus I square plus 1. Now if you see, these terms are same, so I can cancel it out or I can divide it. Okay, fine. Now what is remaining is only these two terms. So this is one of the method. So you can proceed with writing the values of these individual terms also. So you will be getting the same answer at the end. Okay, so now how to proceed? So we have I to the power. Now 384 can be written in terms of 4n. So 384 you divide by 4. So what you will be getting? So 3 9s are 4 9s are 36, 6. So 96 into 4 is 384. So 4 into 96 divided by 374. So 374 divided by 4. So 4 9s are 36, 14. 4 3s are 12, 2 remainder. Okay. So this I can write I to the power 4 into 93 plus 2, because there is a remainder after dividing. So this is in the form I to the power 4n. So I to the power 4n is 1. So value is 1 divided by, this is I to the power 4 into 93 into I square. So again 1 by I to the power 4 into 93 is in I to the power 4n format. So this is 1 into I square. Now what is the value of I square? I square value is minus 1. So it is 1 by minus 1, which is equal to minus 1. So this is how we solve the numericals on based on these concepts. Okay. So I hope this is clear. So you can work out any number of numericals based on this concept. If you have any doubts or if you have any queries, you can write to me, or you can write it in the comment box. Okay. So that's it for today. If you liked my tutorial, please write to me in the comment box. Do share my videos and subscribe my channel. Thank you. Let us meet with the next video.